Graphing ordered pairs. To graph an ordered pair, let's say such as 3, 2. Start at the origin, which is 0, 0. That's where your x and your y axis intersect. So this is our origin, 0, 0. And then you move left or right on the x-axis depending on the first number. So in our case, with our example of 3, 2, the first number is 3. Since it's positive, that tells us to move to the right. And since it's 3, we're moving to the right 3 from the origin. So 1, 2, 3. Then you move up or down from there depending on the second number. In our example, the second number is a positive 2, so that tells us to go from 3 on the x-axis, go up 2. And then you would plot the point. So where the star is, that is the ordered pair. That's the coordinate 3, 2. So you can follow these 4 directions every single time when you're trying to graph an ordered pair. Let's look at a different example. It says to graph -3, 4. So we're going to start at the origin. Again, that's here at the point 0, 0, where your x and your y axis are meeting. So then because the first number is a -3, we're going to move 3 to the left. 1, 2, 3. Right, it's now to the left because -3, the first number is negative, so negative is in the left direction. And then from -3 on the x-axis, we're going to move up 4 because the second number is a positive 4. So 1, 2, 3, 4. That's where we would plot our point. Where the smiley face is, that is the ordered pair on the graph -3, 4. Here's another example. It says to graph -3 1/2, -2. So we start at the origin, 0, 0. Again, where the x and the y axis are intersecting. And then we're moving 3 1/2 left. That's because the first number is -3 1/2. So we're going 1, 2, 3, and then halfway between -3 and -4 to show -3 1/2 in the left direction. And then we're from that place on the x-axis, we're going to go down 2 because the second number is a -2. So from there, we're going down 2. So then the smiley face, that's where that ordered pair would be. That's the ordered pair on the graph, -3 1/2, -2. Here's another example. It says to graph 5, -3.25. So we start at the origin at the ordered pair 0, 0, where the x and the y axis are intersecting. And then the first number in the ordered pair is 5, so that's why we're going to go 5 to the right from the origin. 1, 2, 3, 4, 5. And from that spot on the x-axis, we're then going to go down 3.25 because of the -3.25, that second number. So 1, 2, 3, and 0.25. So somewhere in between -3 and -4, a little bit closer to -3. So the star is on that ordered pair of 5 and -3.25. So let's get some more practice, and instead of having it graphed for us, let's actually graph them ourselves. It says to first place the star on 2.5, 5 in quadrant 1. So 2.5, 5, we're always going to start when we plot points at the origin. So I'm going to mark the origin on my graph to help me and always know that's where I'm starting. So if the first number is 2.5, we're going right 2 1/2, so here, roughly on the x-axis, and then we're going up 5 because the second number is a positive 5. So we're going up 1, 2, 3, 4, 5. So this right here, we would place the star here on our graph. Then it says to place the triangle on -4, 4. That'll be in quadrant 2. So we have -4. We're starting at the origin. That will then tell me to go left 4. So I'm going to go 1, 2, 3, 4 to the left, and then up 4 from the positive 4y value. So I'm going up 1, 2, 3, 4. So that is where I would place the triangle in quadrant 2. Then it says to place the square on -6 and -3 1/2. So I'm going to place the square. I'm starting at the origin, and then the -6 says to go left 6. So 1, 2, 3, 4, 5, 6. And then it says the second number is -3 1/2. So that says from -6 on the x-axis to go down 1, 2, 3 1/2. So that point, and -3 1/2, somewhere in between -3 and -4, you estimate roughly halfway between the boxes. That's where we're placing the square. And then the circle we're going to place on 1, -4 in quadrant 4. So we're starting at the origin. The first number of 1 tells us to go right 1. And then the second number of -4 tells us to go down 4. So 1, 2, 3, 4. So here is the ordered pair of 1, -4. That's where we would place the circle. So here you can see is where the star, triangle, square, and circle should go after we've moved them, after the movement of left or right, and then up or down. And you can even use the numbers themselves to show and check that you're in the right quadrants, right? If we draw our quadrant C, this would be quadrant 1, 2, 3, and 4. So it's good to make sure that the star is in quadrant 1, the triangle is in quadrant 2, the square is in quadrant 3, and the circle is in quadrant 4. It's a good way to check your work. And even the numbers themselves, the signs of the ordered pairs should match what they should be in the first quadrant, second quadrant, third quadrant, and fourth quadrant as well. You can use all these different ways to check your work. So let's do some more. Here we have placed the circle on -6, -5. So again, we're always going to start at the origin when we're plotting points. So here's the origin, 0, 0. So placing the circle -6, -5. So we have, that means the first number of -6 says we're going left 6. So 1, 2, 3, 4, 5, 6 to the left. And then -5, the second number tells us to go down 5. So 1, 2, 3, 4, 5. So this is where the circle will go, -6, -5. Then we have placed the star on 4 1/3. So that's 4 1/3, comma 6. So we will have, starting at the origin, 4 1/3 tells us to go in the positive right direction on the x-axis. 1, 2, 3, 4 1/3. So we're estimating a third to be there, a little bit closer to 4. And then the second number of 6 tells us to go up 1, 2, 3, 4, 5, 6. So that ordered pair, that coordinate there, is where we will place the star. We have the triangle is going on -4.25, comma 2. So starting at the origin, the -4.25 tells us that first number tells us to go to the left 1, 2, 3, 4 1/4, so 4.25, approximately there. And this second number of 2 tells us to go up 2. So the triangle will go there. Finally, we have to place the square on 3, -1. So from the origin, the first number of 3 says to go to the right 3. And then -1, the second number, tells us to go down 1. So we'll place the square there. So let's actually place our shapes. So we have our circle, star, triangle, and square, and then it's asking in which quadrant is the circle. So if we label our quadrants using the capital C trick, we would label them quadrant 1, 2, 3, and quadrant 4. So our green circle is over here. That is plotted in the third quadrant, or quadrant 3. So you can use the circle method to help you. We also know that the circle is a negative signed ordered pair, which matches with all the ordered pairs in quadrant 3. So you can actually look at the graph or use the signs of the ordered pair as well. Now let's take a look at these. So first we have place the circle on -4, -3. So let's mark our origin. There's 0, 0. So -4, -3 tells us to go to the left 4 and to go down 3. So that's where we would put our green circle. Then it says to place the star on 4, 3. So we would have our star on, starting from the origin. That tells us to go right 1, 2, 3, 4. And then the second number of 3 tells us to go up 3. So there's where we would mark the star. The triangle's going on -4, 3. So that tells us from the origin to go to the left 4 and up 3. So that's where we will place the triangle. And then placing the square on 4, -3. So that tells us to go right 4 and down 3. So that's where we would place the square. And these 4 points specifically, something interesting happens when you graph them. You should start to notice something about the location of the points in relation to each other and start to maybe see some patterns. You might even be able to see the patterns if you just look at the coordinates themselves, but then visually you can see what's special about them on the graph. So if we actually move our circle, triangle, star, and square, you can see that when two ordered pairs differ by only their signs, the locations of the points are reflections of each other across one or both axes. Notice we have the green circle point was -4, -3, and the triangle is -4, 3. So the ordered pair is differing by the sign. They have the same x value, but they have different y values. This one has a -3y value, and this one has a +3y value. So they're on that same -4x coordinate, but you can see one is up 3 while one is down 3. That's a reflection across the x-axis. This is versus if we, let's say, compare the circle to the square. The circle is located at -4, -3, but the square is located at 4, -3. So here, they actually have the same y values here, right? Looking at -4, -3, and 4, -3. Now they have the same y values of -3. Right? They're both located here, but now one is a -4x value and one is a +4x value. So they're differing in 4 units, but one is plus and one is minus. That is a reflection in the y-axis. So when you have these coordinates with the same numbers but only differing by their signs, you end up with these reflections across one or both axes. If we compare the circle to the star, you can see that the circle and the star, let's look at those. The circle is located at -4, -3, and the star is at +4, +3. So that is actually the complete opposite of both the x and the y, and as you can see, that is a reflection across both axes. You're reflecting across the x and the y to get at that location. So these 4 points are actually special because you are using 4 and 3, you're just changing the signs whether it be just the x value, the y value, or both, and then you can see how it relates and is reflections over the axes. This is compared to just random points if you had, let's say, 4, 3, and 4, 5, or 4, 3, and negative 1, 2. Those points aren't going to have that special relationship. Let's continue to look at some other special relationships. Let's look here. What if we have the points 4, 3, and negative 4, 3? We know that that shows a reflection across the y-axis. What generalization can we make now about the coordinates of a point when it is reflected across the y-axis? So when a point is reflected across the y-axis, the sign of the x-coordinate switches and the y-coordinate stays the same. You have the point 4, 3, and negative 4, 3. So again, the sign of the x-coordinate switches. You went from a 4 to a negative 4, and the y-coordinate stays the same. They're both 3. So this is special for any point that is now reflected across the y-axis. We can make that generalization. What about these two? Here we have the points 4, 3, and 4, negative 3. This shows a reflection across now the x-axis. So what generalization can you make about the coordinates of any point when it is reflected across the x-axis? So we can make the generalization that when a point is reflected across the x-axis, the sign of the y-coordinate switches and the x-coordinate now stays the same. Right? We had 4 and 3. Now we still have 4, the same x value, but now we have negative 3. So again, it's like you'll have the same x value, but the y value will switch when any point is reflected across the x-axis. Let's look here. We have the points 4, 3, and negative 4, negative 3. Those are showing a reflection across both the x and y axes. Think about now what generalizations we can make about any point and its coordinates when reflected across the x and y axis. So when a point is reflected across the x and y axis, the signs of both the x coordinate and the y coordinate will switch. We went from a positive 4, positive 3 to a negative 4 and negative 3. So now any coordinates, any point, you can just switch both of the signs of the coordinates, and that will give you a reflection about the x and the y axis. So now let's continue to look at ordered pairs, maybe not special ordered pairs, but let's make sure we can work backwards. And if we're given an ordered pair on a graph, we would be able to match it up with what that coordinate looked like with numbers. So for example, we have 1, 2, 3, 4, 5 ordered pairs on the graph. So we want to match them up with the ordered pairs that are given over here. And actually 6, I missed this one over here, but we're going to match up all of these ordered pairs with where they belong on the graph. So again, we have to always reference 0, 0. We have to reference the origin first, and then we can see how much are we first moving to the left or to the right. That will give us our first number, and then we have to see how much we're moving up or down. That will give us the second number. So let's first try out this point here. So from the origin, if I want to get to that point, if I were to give directions to somebody on how to get to that location on the graph, first moving left or right, I would have to tell them to move left 1, 2, 3. So that's going to mean the first number of the ordered pair is negative 3. And then I would have to tell them to move up 2. So that means the second number is going to be a positive 2. So that ordered pair is negative 3, 2, which is matching up with the point F. So we've located that point on the graph. So let's do that now for the other 5 points. So we have, let's maybe do this point. Let's do one more together. So we have this point here. So in fact, this point, we actually, if I were to tell someone how to get to that point on the graph, starting from the origin, I'm going to tell them not to move left or right at all. I want them to stay on the y-axis. So the first point I'm actually going to tell them is 0. I don't want them to move at all left or right. I want them to just move up 1, 2, 3, 4, 5, 6 spaces. So the second number can then be a positive 6. So that will give us 0, 6, which is matching up with the point for D. So we've located that point on the graph. Let's continue to find the other 4. So here we have F and D we located before. So A, -9, -4.5 is this point over here. Then we have 2, -2 is point B. We have 9 1/4, 0. That's going all the way to the right, 9 1/4 unit, and then not moving up or down at all, right? That's what that 0 means. Just very similar to 0, 6, except one is telling you not to move left or right at all. That's the 0, 6. And then one is the other one, the 9 1/4, 0. That's telling you not to move at all up or down. So it's really important, I would say, when graphing ordered pairs, when trying to match up ordered pairs, whether trying to write ordered pairs, you really have to remember, always start with 0, 0. Look for that reference and then see how much you're moving left or right first, and then up or down to get that x and y coordinate.